Good day, students. On this clip, we're going to be going over an example on how to find the value of 6 trig ratios of angles in standard position. Okay, so to get started, we're going to write down the instructions for the example we're working on, which is that for the given trig ratio, draw the graph of theta. Draw the graph of theta in standard position okay, and find the value of all 6 trig ratios and verify that your results are correct using the identities. There are 3 identities we're going to be using the identities sine squared theta plus cosine squared theta equals 1 plus tan squared theta equals secant squared theta, and the third identity is 1 plus cotangent squared theta equals cosecant squared theta. Okay, so these are the 3 identities we're going to use to prove that our answers are correct. Okay, so let's take a look at question number 1. We have the trig ratio cotangent theta equals negative root 2 over 5, and theta is between pi over 2 and pi. So pi over 2 is less than theta, and theta is less than pi. Alright, so in order for us to find all 6 trig ratios, we need to know our opposite, adjacent, and hypotenuse. To determine the sides we have and the sides we need, what we'll just do is we'll draw a coordinate system. We're in quadrant 2, as you can see here, so let's draw a coordinate system. There goes my y-axis, and there goes my x-axis. Now, let's label our coordinates. So this is 0, which is a positive x. This is pi over 2, which is the positive y. This is pi, which is negative x. This is 3 pi over 2, negative y, and this is also 2 pi. Alright? Okay, so we know that we're between pi over 2 and pi, so what we'll do is we'll draw the terminal side right here. And remember, our angle is the reference angle. Since it's in standard position, we always have to calibrate our angle or measure our angle starting from the x-axis. So theta is going to be this angle right here. So this is theta. Alright? Now let's go ahead and complete our triangle. This is theta. This is a completed triangle like this. Alright, now that I have a completed triangle, which is the opposite, adjacent, and hypotenuse? Well, this is a 90-degree angle, so that tells me that this is going to be the longest side. So this is my h for my hypotenuse. Alright, and then the side that's opposite your theta, reference angle, this side right here is known as your opposite. Okay, and then the other side is your adjacent. Alright, now let's put in the measures. So cotangent is what I know, so I don't know what this is. It could be opposite, adjacent, hypotenuse. But to determine what this is, I'm going to write SOHCAHTOA. See that on the side here. SOHCAHTOA. I know that cotangent is related to tan. So since tan is opposite of adjacent, that means cotangent is the reciprocal, which is adjacent over opposite. So this is going to be my adjacent. Okay, and this is my opposite, because cotangent is a reciprocal of tan. Alright, so with that in mind, I'm going to call this opposite. This side right here is going to be 5. This is 5. And then the adjacent is root 2. So the question is, where does the negative go? To the 5 or to the 2? Since this goes up, it's positive. Since the adjacent goes to the left, it's negative. So my adjacent is negative. We're missing the hypotenuse, so that's the side we need to find to be able to find those 6 trig ratios. Okay, so what we're going to do is we're going to use the variation of the Pythagorean theorem, which is that a square adjacent square plus o square opposite square equals h square. Alright, so let's plug it in. We're going to have adjacent is negative root 2 square plus o square, which is 5 square, equals h square. Alright, let's work this out. Negative root 2 square is 2 plus 5 square is 25 equals h square. H equals, h square equals 25. 27 plus 25 plus 2 is 27. Now we're going to root both sides to get the value of h. So root both sides. So we're going to have h equals 3 root 3. Okay? So how did I get 3 root 3? All you just do is you take 27. Let's do it on the side here. Take 27 and break it down. Take out a 3. You're left with 9. Take out another 3. You're left with 3. These two 3's break out as 1 because they repeat. So the square root of 3 times 3 is just 3. So 27 is basically 3 root 3, as indicated here. Alright? Okay, so let's put in that measure back into a triangle. So we now know what all the 3 sides measure. So h equals 3 root 3. Alright, now let's go ahead and figure out the value of all 6 trig ratios. So let's start with sine. Well, in order to know what they are, to help me stay organized, let me just put my circle up here to guide me. So, Alright, so sine theta. Sine theta, my reference angle is opposite of a hypotenuse, okay? The opposite is 5, hypotenuse is 3 root 3. Alright? We cannot have a square root in the denominator, so we're going to rationalize using root 3 top and bottom. So that's going to give us 5 root 3 over 3 times 3, which is 5 root 3 over 9. Alright, now let's look for our reciprocal of sine. The reciprocal of sine is cosecant, so cosecant theta is hypotenuse over opposite. You just reciprocate that, which equals, instead of reciprocating the final answer, which would give me a radical in the denominator, I'll reciprocate O and H. Unrationalized, that will give me 3 root 3 over 5, so I don't have to do any work rationalizing. Okay? Alright, the next one is cosine. Cosine theta, we know from Ka, is adjacent of a hypotenuse. Okay? The adjacent is negative root 2. And the hypotenuse is, let's see what it is, 3 root 3. We have a situation where we have a radical on the bottom again, so we need to rationalize the denominator. Root 3 top and bottom, root 3, and then root 3. So that's going to yield negative root 6 over 3 times 3, which is negative root 6 over 9. Alright, so there you have it. Okay, now the reciprocal of cosine is secant theta. So secant theta, you reciprocate adjacent of a hypotenuse. You're going to get hypotenuse of adjacent. So I'm just going to, it doesn't really matter which one I reciprocate here. Let me reciprocate the original. So that's going to be negative 3 root 3 over root 2. I can have a square root on the bottom, so root 2 top and bottom. So my answer is going to become negative 3 root 6 over 2. Alright, that's secant. 2 more to go. Tan theta is opposite over adjacent from TOA. My opposite is 5. My adjacent is negative root 2. This also needs to be rationalized, so times it by root 2 top and bottom. Root 2 root 2. So that yields negative 5 root 2 over 2. Alright, so that's tangent. And then cotangent, we already knew what cotangent was because that's the original problem. Cotangent is adjacent over opposite. which is negative root 2 over 5. Okay, so these are our 6 trig ratios, and we're now going to try and prove that they're correct. So let's organize them on the side here, and then we're going to start making work with our proof. Okay, so sine theta is 5 root 3 over 9. Cosecant theta is 3 root 3 over 5. Cosine theta is negative root 6 over 9. And then secant theta is negative 3 root 6 over 2. Tan theta is negative 5 root 2 over 2. And then cotangent theta is negative root 2 over 5. Alright, it's negative. Alright, now let's go ahead and do our proof to make sure, or our check to make sure that our answers are correct. Alright, so we're going to label this check. Alright, so check. So the first check is using the first identity, the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. So I'm going to plug this in and see if I end up with a true statement, okay? Alright, so sine theta is 5 root 3 over 9. So it's 5 root 3 over 9 squared plus cosine is negative root 6 over 9. Negative root 6 over 9 squared. Is it equal to 1? Is it? If I work this out, I'll get 25 times 3 over 81 plus 6 over 81. If I add these two, do I get 1? Let's work it out. 75 over 81 plus 6 over 81. Is it equal to 1? 75 plus 6 is 81. So it's 81 over 81 equal 1. Absolutely 1 equals 1, right? So our answer checks out. So that means that sine and cosine are accurate. Alright, we have 2 to verify. We have 4 more to go. To do the next verification, we're going to use the next Pythagorean identity. So I'm going to erase this first. So the next Pythagorean identity I'm going to use is the identity 1 plus tan squared theta. 1 plus tan squared theta equals secant squared theta. Okay? We're going to have 1 plus tan squared theta. Tan theta is negative 5 root 2 over 2. So if I square this, I get secant theta is negative 3 root 6 over 2. Alright? So let's simplify both sides and see if we get a true statement. Okay? So this becomes 1 plus, now this square, I'm going to square the 5 and the 2, so it becomes 25 times the square root of 2 squared is 2 over 4. On the right side, I'm going to have 9 times 6 over 4. Simplifying further, we have 1 plus 50 over 4. And on the right side, you times it, 9 times 6 is 54 over 4. Okay? For this side, we'll find the denominator. I'll find the LCD, so it times it by 4 top and bottom. So we're going to have 4 over 4 plus 50 over 4. Is it equal to 54 over 4? Absolutely, right? 54 over 4 equals 54 over 4. So our answer checks out. That tells me that my tan and secant results are accurate. Alright, we have 4 checked out, and then we have 2 more to go. Alright, to prove that the last pair of answers we have are accurate, we're going to use the identity for the cotan and cosecant. Alright? Alright, so let's go ahead and do it. So to get started, we're going to write down the identity, which is that 1 plus cotangent squared theta equals cosecant squared theta. Alright, so we have 1 plus cotangent theta is negative root 2 over 5. So that one's squared. And then cosecant theta is 3 root 3 over 5 squared. Let's work that out. So we're going to have 1 plus If you square root 2, you get 2 over 25. Is it equal to, if you square this independently, you have 9 times 3 over 25. Okay? On the right side, you have to find the LCD, so times this by 25 top and bottom. 25, 25. So the question is, this 25 over 25 plus 2 over 25, is it equal to 27 over 25? Alright? So you notice that 27 over 25 equals 27 over 25. So our last answer checks. That means all our results are accurate. So there you have it. We're now confident that the results are indeed correct. Okay? So that's that. Thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel just by clicking up here. You can share this video with your friends via Facebook or Twitter. More videos can be found on mathyourself.com. Thanks again and have a wonderful day.